I get free time. Four times 9 is 36.
Good afternoon, everybody. I hope you're doing well today.
That's what you got from me, right?
Yeah, I got
We're going to come back as a whole group. And today's warm-up was very specifically designed to review some major ideas that you've learned recently. One is a review of the last lesson, the last major idea, and one part is a review of something that you're going to need for today. So let's see how we did. Colored pens are now up. All right, number one, what'd you get? I got student number 16 and student number 6.
2x squared plus 3x minus 14.
Okay, student number 6. Mark your answers correct or incorrect. If you get something wrong, write down the correct answer. See if you can figure out where you went wrong. Number 2, what'd you get? I got student 7 and student 12.
6y squared plus 35x plus 26.
Okay, student number 12. 6y squared plus 35y plus 36. And number 3, student number 8 and student number 19.
3n squared minus 21n plus 35.
Okay, student number 19. Very good. Factoring. What we've been working on for quite some time now. Factoring. Let's see how we did for number 4. I got student 10 and student 9.
X plus 8 times x.
Okay?
X plus 8 times x.
So you both agree it is x minus 4 times x plus 8 or x plus 8 times x minus 4. Each one of those binomials is a factor. So that's a factor and that's a factor. You can switch factors around. That doesn't make a difference. All right, number 5. I got student 5 and student number 2.
Z plus 3 times z plus 12.
Okay?
Z plus 12 times z plus 3.
So it's the same thing, but you flip-flop the factors, and that is totally fine. And number 6, I got student number 1 and student number 3. Student number 1, what'd you get?
H minus 9 times h minus 8.
Okay?
H minus 9 times H minus 8.
That is correct. Very nicely done. So, a warm-up is kind of a little bit of an informal daily quiz to see how you're doing on lots of different ideas. It's okay to make mistakes on warm-ups. It's not the biggest deal in the world, but if you can do well on warm-ups, that does tell me a lot. So I am going to survey now. Give me a thumbs up if you got all of them correct. Okay, put your thumbs down. Give me a thumbs up if you made a mistake somewhere, got something wrong, but you already figured out where you went wrong. Nice. Very good. Good. Put your thumbs down. Shannon, if I could put you on the spot, which one did you go wrong on, and what was the issue?
Number 3, I had 21n minus 5n, and I put in the addition sign.
Right here?
Yeah, but when I was solving,
What do you mean when you were solving it?
like before 26.
Oh, when you were actually going through the process, what method did you use? So you used FOIL, and while you were doing it, you just made a small mistake along the way. I got you now. Okay. So you used FOIL. Okay, good. So let's look at numbers 1 through 3. Let's chunk them together. Give me a thumbs up if you used FOIL for numbers 1 through 3. A lot of people using FOIL. Good. Put your thumbs down. Does anyone have any questions or concerns about anything that we did during the warm-up? Any concerns about anything? Okay. So, we're going to jump right into today. You already know the title of today's lesson, and it looks almost exactly the same as the title of the previous lesson, with one tiny, itty-bitty, minuscule difference. Tiny, itty-bitty, minuscule difference. Everything that we've factored so far using unwrapping FOIL has had a 1 in this position right here. Today we're going to start exploring what happens if that number is not a 1. This tiny little difference actually dramatically changes what we have to do. Dramatically. So let's talk about what our goal is. Our goal eventually is to be able to solve this problem and ones like it. Don't write it down, just look. So over the next week, week and a half, you're actually going to learn how to apply the vertical motion model and how to use it to solve some interesting problems. So in this situation, I'm describing a scenario with a tennis player. To really illustrate the vertical motion model, I'm going to actually just hide this for a moment. And did I introduce the vertical motion model to you guys before?
Yeah.
No. Yes? We did? Okay. Maybe. So I'm going to use this, okay? Make sure you stay on your toes because this might come flying at you at a time when you're not expecting it. So, athletes, and whether you're an athlete or not doesn't matter. I'm sure you've seen an athlete somewhere in your lifetime doing something. Very frequently we use objects as part of the game. And you can actually do a very good job of predicting where the object is going to go, how far it's going to go, how long it's going to take to get there, using the vertical motion model. Now, there's an aspect of the vertical motion model, Mark, that is very difficult to find without a very scientific digital tool. Okay? So let's talk a little bit about it. The vertical motion model has 4 letters, 4 variables. To find anything, you have to fill in all of them except one. Very often, the T is time. T will be the one that we're going to find. Make sure you're looking up here so you can see. H is the ending height. S is the starting height. So for example, if I reach back like this to throw the ball, the starting height is way up here, maybe 5'9" tall. And if I then throw it to Sean like that, and he catches it, he caught it right here, sitting down. That was about 3 feet off the ground. Starting height, ending height. If he had not caught it and just let it go to the ground, that would be a different ending height. So those are 2 important pieces of information. Those are easy to find because we can measure them. Right? If I just pause, I can measure it. V is very difficult to measure, and you need a speed gun or some sort of device that can measure vertical velocity. In baseball, they use a speed gun to measure a pitcher's velocity. So we need something to measure that. But if I were to give you that information, you could actually figure out everything else. And using that, we can predict how long the ball is going to be in the air. So for example, if I throw it to Sean again like this, that's one situation. If I throw it like this, that would have been very different because I would have applied much stronger vertical velocity and it would have gone much faster. Okay? So it's a very powerful model. So now back to the scenario I presented here. And this is a question that I did with my students last year. So tennis, hopefully you've seen tennis somewhere. Let's play with a racket. We're going to pretend that this is my racket. And it says that the athlete hits the tennis ball with the initial height of 8 feet, which means the ball's way up in the air up here. And the tennis player goes up and hits the ball like that back to the other player. When he makes contact, he or she makes contact with the ball like that, the vertical velocity is 62 feet per second. Feet per second. So that's going pretty fast. Okay? The ball then goes up in the air over to the other side. So the question is, how long does the other player have to move around the court to figure out where they should go to hit the ball next? Athletes do this instinctively. Athletes don't really sit there and do calculations. They do it instinctively, meaning they just know in their gut where the ball's going to go. But actually what's happening is their mind is so incredibly powerful that it's doing calculations, you just don't realize it. Okay? So the question is, how long would the tennis player on the other side have to move around the court before they had to address the ball? So, using the vertical motion model, we fill in some of the information from the text of the question, and then using factoring, you already know how to do this part. Today you're going to learn how to do this part, and then we haven't learned how to solve yet, but that's the last piece. And when we solve it, we end up with two different answers. We end up with 4 and negative 1/8. Time can't be negative, so we disregard that answer, and we end up with 4. And so what that means is the other player would have 4 seconds to move around the court before they had to actually address the ball, or until the ball was going to hit the ground. Okay? So our goal is to be able to work with something like this. Does anyone have any questions? Any observations or anything? Okay, so we haven't learned anything yet. So now let's start learning. I would like everyone to copy down this multiplication problem right here, please, and disregard the other ones. All I ask you to do is copy it down. Now, I would like you to FOIL it just like you did during today's warm-up. You guys told me that you all did FOIL. I'm pretty sure either everyone or almost everyone had their thumbs up. But you may not write down anything until you actually are done. Then you may write down the results. Everyone understand? We did this once before. You may not write anything except for the starting multiplication problem and the end result. You may not write anything down in between. You may do things mentally. Any questions? Go. Give me a thumbs up if you've got it already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. Put your thumbs down. So my students, you didn't get it yet. You didn't do anything wrong. You did not do a thing wrong. But the goal here was not necessarily to get it right or wrong, it was just to start observing. So let's see who was able to get it. Christian, what'd you get?
3x squared plus 12x minus 2.
Okay. I lost track of who my other thumbs up people were. Who's my other thumbs up people? Montrevious, what'd you get?
4x squared plus 12x minus
Okay, so you disagree slightly. It is 3x squared plus 12x minus 15. So, it doesn't matter if you got it right or wrong. But we need to start observing and we need to start trying to figure some things out. So, you end up with 3 numbers. We started with 4. 1, 2, 3, 4. The question is, what is the connection between the 4 numbers and the 3 resulting numbers? That's the big question. I'm not telling you what the connection is, but there is a connection. So it's your job over the next little while to try and figure it out. So write down the middle multiplication problem, please. Do not write down the last one. And I would like you to FOIL it, but you may not write down anything until you're done, and then write down the results. Give me a thumbs up if you've got it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, put your thumbs down. Andrew, what'd you get?
2x squared plus 4x plus 2.
Daniela, what'd you get?
2x squared plus 4x.
So the question is again, what is the connection between the 4 numbers here and the 3 numbers that result here? Keep in mind, this is not today's lesson. This is a review. And I'm hoping that you will start seeing the patterns so that today's lesson won't seem so difficult. All right, let's try one more. Try this last one. Because I had about half the class were getting it, and I want to give the other half the class a chance to see if they can start seeing it. Can't write down anything until you get the results. All right, give me a thumbs up if you've got it. 1, 2, 3, 4, 5, 6, 7. Okay, put your thumbs down. All right, Diane and then Aaron. Diane, what'd you get?
10x squared minus 22x minus 24.
What'd you get?
10x squared plus 22x minus 24.
So let me ask my students who were successful, how did you store all that information in your brain? Because I told you that you weren't allowed to write anything down until the end. You had all that stuff to remember. How'd you do it? Is it magic or what'd you do? Mark, what'd you do?
Well, like for the first 2, it's automatically like in my head I already was saying 10x squared, so I remember that already. And then with the last one, I just went lower because it's already 4 times -6, and then I already know those already, and I just multiply. I had the what is it? It was 30 -30 plus -8, no, +8.
So did you do it in that order? Because that would be great, because that's how I do it as well. I immediately figure out this one, and I then figure out that one, and then I work on the middle one. Give me a thumbs up if you kind of naturally started doing that over the course of... Good. Good. Put your thumbs down. If you have another way to do it, that's fine. Doesn't matter. But hopefully you see that the first term and the last term are the easier parts to find. It's the middle term that takes a little bit of an effort, but he described it really well. He knew that he was going to multiply these, and then add those results together. So he was able to hold all that information in his head. That was pretty good. And a lot of you shared that you were as well. Does anyone have any questions? Okay, so again, that's not today's lesson. Today's lesson is to go backwards. So, I would like you to write down the first one. And what I would like you to try and do is figure out what would have to go here and what would have to go here so this was the result. Go. Figure it out? Got a few people nodding their heads. Give me a thumbs up if you've got it. 1, 2, 3, 4, 5, 6. Okay, put your thumbs down. I'd like everybody to pause. And again, please understand that I'm not trying to make you feel bad in any way. You did not do anything wrong. I'm being 100% honest. I am not having you do this, and that's going to be it. Trust me. All right. So, Melinda, what did you get for the two factors?
5x minus 2 times x minus 3.
Oop, what happened? Oop, my mistake. Sorry. That's correct.
It doesn't matter which term you use, you put the minus 2 or minus 3.
Yes, it does. So if you have 5x minus 3, let's check. Okay? So don't just take my word for it. 5x minus 3 times x minus 2. Seems like it should work, right? Because it looks almost the same. Now FOIL it. Oops. What do we end up with? Emily?
Negative 13.
You end up with a negative 13x as the middle term. And that's not what we were looking for. So, but you just revealed something really important. How do we check if you got the right answer? FOIL it. You will always know whether you got it right. Okay, one more and then that's going to be it. Go ahead and try the middle one. See if you can find the two factors that will multiply. We will not be doing this one. Got some people who got it already? Two people who got it? All right. So normally on a challenging question I would give you much more time, but there is a reason. I'm being very deliberate. Okay, Ethan, what'd you get?
I got 9x minus 1 to the quantity of x plus
9x minus 1 times x plus 2. That is the only combination of factors that will work.
Is there like a secret way that we can know which one to put it in without boiling it?
That's a good question. Well, I'm going to help you to be a little bit more practical with what you're doing. Because right now, the technique that you guys are using is called guess and check. Kind of take a guess, see if it works. If it does, awesome. If it doesn't, try again. That can be great with something like this, where the numbers are all very small numbers. Not a big deal. But when you got bigger numbers and more combinations, it becomes impractical. So I am going to teach you a practical method, okay? So I'm going to start right now. I'm going to teach you the method for the first one that I asked you to do. So I actually don't want you to write yet. I actually want you to put your pencil down. And I'm going to do some modeling, and I'm going to talk you through my mental process as I do it. I want you to pay attention, and I hope that you can either model my thought process or just take my process and develop your own. But here's the goal. And it's written similarly to what I wrote last time, which is we're going to try and find two factors of A, which is the number out front, and two factors of C, which is the number in the back, that somehow multiply and then add to get the middle number. Right here. So here's the process, okay? First you take A, and you take C, and you list all the factors of them. So I already did that part for you. Here's all the factors for 5. Here's all the factors for 6. I also wrote them kind of in pairs. Even if you were successful, by the way, a moment ago, you need to pay close attention. So now what I'm going to do is I'm going to try and multiply one number from the left column times a number in the right. Then I'm going to multiply another number in the left times a number in the right, and then add the results together to see if I get negative 17. Okay, so watch. So let's try 1 times 1, 5 times 6. 1 times 1 is 1. 5 times 6 is 30. 30 plus 1 is 31. Not the right combination. Let me back up. Let me try it the other way. Let's try 1 times 6 and then 5 times 1. Maybe that's it. 1 times 6 is 6. 5 times 1 is 5. 6 plus 5 is 11. That didn't work either. Okay, back to the drawing board. Let me try 1 and 5 and negative 1 and negative 6. So I'll try this way. So 1 times negative 1 is negative 1. 5 times negative 6 is negative 30. That comes out to negative 31. Still didn't figure it out. All right, back again. I'm going to try 1 times negative 6 and 5 times negative 1. That's got to be it. 1 times negative 6 is negative 6. 5 times negative 1 is negative 5. That's negative 11. Thought I had it there. Okay, back again. Let's try the 1 and the 5 and the 2 and the 3. 1 times 2 and then 5 times 3. So 1 times 2 is 2. 5 times 3 is 15. 2 and 15 is 17. Still didn't get it. Anyone have a thought at this point? Diane? Okay. So you think I should try the -1 and the -5 with the 2 and 3? Okay, so let's try it. So -1 times 2 is -2, -5 times 3 is -15, -2 and -15 is -17. But I could also do this. One times -2 is -2. 5 times -3 is -15. That also comes out to -17. How do we know which one to use? Well, I actually shouldn't have put these here because we don't want the first number to be negative. We'll talk more about that in a little while. So this is the combination that we want to use. And so now I have to figure out, stick with me, trust me, stick with me, I know you're getting a little tired, but now I actually have to write it out. So now one of these is going to be a coefficient of x in one term, and one of them is going to be the coefficient, so I'm going to have 5x and I'm going to have x. And now I have to figure out where the -2 and the -3 go. So I could try the -2 and the -3 this way and just see if it works. And I can FOIL it, and it works. So I got it, and it only took me like 5-6 minutes to do it. Right? So one problem, 5-6 minutes, not a big deal. You're in Algebra 1 honors, that's just kind of the way it is. So I intentionally asked you not to write anything so that you could focus on my mental process as I was talking you through it. That's what was really going on in my head. Normally I wouldn't talk out loud, I would just let my mind do the work. Does anyone have any questions about what we did? Okay? So now we can go back, and I could give you this one, and you could try it, right? But stop. My first, 3 years teaching Algebra 1 honors, this is exactly how I taught it. And this is what all my students did. And then someone taught me something and made it a lot easier. This is how I'm supposed to teach it. But I'm going to teach you something different. So, but it's kind of a secret. So I'm going to tell you, but I'm not supposed to. And I'm even going to show you, and I even made up a cheat sheet for you, but I'm not supposed to. So because I'm going to get observed sometime this week. So if Dr. Senden walks in, I'm going to have to stop doing it, and I'm going to have to pretend like I was doing this. If Dr. Brown walks in, and he was a math teacher before he became an assistant principal, he's really going to be looking. So I'm going to stop doing the easier way, and I'm going to pretend like, and you're going to have to just play along. Because if you guys get me in trouble, I'm bringing you down with me. I'm also going to give you a little cheat sheet. And they can't see it on your desk, so if they walk in, you have to slide it under your stuff. It's small, so I made it small, so it's not a big deal. Okay, but I also gave it a very silly, very stupid name, because I didn't come up with a good name. So I'm going to teach you the trick. Okay? So I'm going to teach this to you. And the good part is it works every time. You can't tell anybody. So I'm going to give you a cheat sheet. At the end of class, I'm going to pass around a stapler, and you're going to staple this into this lesson so that you can refer back to it. But the idea is for you to use the cheat sheet today, but by the end of this evening or by tomorrow, you know the trick and can just do it anytime you need to do it. So, Now, one thing I want to say about the trick is that it's a trick, and it relies on a couple of things. One, it relies on you remembering exactly what you're supposed to do, and two, it's not something that you can use for something else. In other words, you can't take the trick and try to apply it to solving an equation like we did at the beginning of the year. It won't make sense. We're going to do some things during the process that don't really make sense. But it works. Just don't tell anybody. Okay, so follow along with me. You are going to need to write some things. You're going to need to add some things in because mine's color, yours is black and white. So here's the trick. And from now on, I will actually call it the trick. So we'll start with the first one. So this is A, this is B, this is C. If you don't know that, then you won't be able to do the trick. First, you start out by multiplying A times C. In this case, it's 9 times negative 2, and we get this number. Take that number. Now that's going to start us off on step 2. Now find factor pairs of negative 18. But we're trying to find the one that adds to the middle number up here. So I've got 1 times negative 18, 9 times negative 2, negative 9 times 2, 6 times negative 3. This adds to negative 17, that adds to positive 7, that's negative 7, that's positive 3. None of these add to 17 except for this one. So far we haven't done anything super tricky, but now here's where the trick actually happens. We take these two numbers, and they are going to be the numerators of two fractions. The denominator of both of them is going to be A. So you put this number over A, and you put this number over A. Now, you're going to have to use your brain. Both fractions must be put into simplest form. If you don't know how to do that, I am not teaching that right now. You can come to my care class and I will help you, but I cannot do that right now. You just have to know how to do it. Negative 1 over 9 is already in simplest form. 18 over 9 is not, and we reduce it to 2 over 1. We are now done with the trick. Now we have to apply it, and here's how it works. The denominator goes in front of the x. The numerator becomes the constant with it. That's one factor. The denominator goes in front of the x. The numerator is the constant that goes with it. That's the other factor. So this fraction, it's like a magic fraction. It's not really a fraction. That fraction turns into this factor here. This magic fraction turns into that factor right there. But you have to remember that the denominators go first and the numerators go with it. What do you think will happen if I accidentally do it the wrong way? Do you think that will work also? Is this going to be the same thing? No, that's incorrect. It has to be the denominators and then the numerators. Why? Because it's a trick. It's not supposed to be logical. It's supposed to be something that just saves us time. Anyone have any questions about the steps before we go ahead and do one together? So you'll notice on your cheat sheet that I put in a second example and I left it all blank. So now you're going to do a step and then you're going to pause. So I would like you to multiply A times C. You can do it mentally if you'd like to and write it down. Go. Good. Someone tell me what you got. Only 2 people can tell me? Well, I'm getting a little worried about the trick now. Natalie? 30. So you should have had 30 here because it was 5 times 6. Now the next is 2 factors of 30 that add to negative 17. Go ahead and find them. Found them already? Montravius, what are they? 15 and negative 2 multiplies to negative 30, not positive 30. Say it again. Negative 15 times negative 2 multiplies to 30 and adds to negative 16. So, to negative 17. Those are the two numbers. So now we come down to the next step. Negative 15 and negative 2, but now we need the denominator. The denominator is going to be a. It is always a. So put this over a, put this over a. Put both fractions in simplest form. Go ahead and do that. You got it? Go ahead, what are they? Very good. Negative 3 over 1, negative 2 over 5. Now the trick is done. Now we just have to apply it to save ourselves all that time. The denominators go in front of the x. The numerators are the constants that go with it. So that's 1x minus 3, 5x minus 2. And we just factored a trinomial using the trick. Anyone have any questions on what we did? Good, now let's do it a bunch of times and make sure we understand. So, we eventually want to be able to answer this question. So I think I've changed my mind about this. I was going to do this part way, but I actually picked the wrong question to do it with. So we're not going to do this question. Don't write example 1 for this. But eventually, within the next week, we are going to be able to answer this question. So this will be example 1. It says example 2. If you would just go ahead and make sure you write example 1. And if I forget to change the labels on the next examples or checkpoints, please feel free to remind me. So, now, we are going to factor these polynomials. But I want you to, if you already started, I want you to stop for a second. Now come over to my whiteboard over here, which I've updated now that we are learning more. You see the title of this whole diagram is called factoring. These are all things that you either already know or are going to know by the end of the week. And not only are these all different factoring methods that you know or will know, but they are actually written in the order that you are to do them. So you actually, anytime you're going to factor, you always start by doing this. No matter what. From now on, you always start by doing GCF first. You have not learned special products yet, so we're going to skip over this and go to unwrap the foil. You want to see if there's a GCF. If there is, do it. Then you want to see if there's a simple trinomial that you can just easily find the factors for like you did during today's warm-up. This should be easy for you now. If we can't do this, then what does that leave us with? The trick. How can you tell if you need the trick? Anyone catch on to how we can tell? I mean, I said it way back at the beginning of the lesson. How can we tell that we need the trick, Natalie? That's exactly right. If there is a number other than 1 in place of A, then you're probably going to need the trick. If there's a 1, then you can just unwrap the foil very easily. Any questions? Good, so now let's jump in. Part A, 12x squared minus 5x minus 3. I would like to factor that. I would like us to factor that. But first I'm going to see if there is a greatest common factor. Is there a greatest common factor? No, there is not, because 12 and 3 have a common factor, but 5 does not. So now we're going to factor using unwrapping the foil. But as Natalie said, that's not a 1, so we're not going to be able to do that. So I'm still going to end up with this. But now I need to Do what? Go ahead, you can say it. The trick. So now we're going to do the trick. You're more than welcome to look at your cheat sheet right now, but by the end of the lesson, you should not be looking anymore. It shouldn't be that hard to remember the steps, and then when you get home tonight, you should probably look once, and then you should not have to look again. So let's go ahead. If you need to look, go ahead. What's the first step in the trick? First step, Deja. Good, and what is it in this case? And what do we get? Very good. Negative 36 is our starting number. Now we need two factors of negative 36, but the two factors have to add up to that number right there. So what are the two factors of negative 36? You got them? And you got them? All right, I'm going to call on you two, but give everyone a chance to see if they can find them. I'll give you a reasonable amount of time. 10 seconds. Got it? All right, Tatiana, what are the two numbers? Okay, and Ethan, what did you think they were? It is going to be negative 9 and 4, because when you multiply them, it comes out to negative 36. When you add them, it comes out to negative 5. That's what we were looking for. But now we're going to use those two numbers, and what do we do with them? What do we do with the numbers? Aaron? Put them over
A.
Put them over A. If you put them over B, unfortunately, the trick will not work. A is 12, so we need to put them both over 12. What's next? Deja, you seem to be doing very well with this aspect in particular. What do we do next? Good, go ahead. You already did it? Okay, but you can do it. Go ahead. Mm-hmm. Very good. And so now the trick is done. We now have the magic. This fraction is magical, and this fraction is magical. The denominators go in front of the x's, and the numerators are the constants that go with it. So this becomes 4x minus 3. And this will be 3x plus 1. And now, before we pat ourselves on the back and tell everyone how awesome we are, we're going to mentally check and see if we got it right, which is what I asked you to do a little while ago. Foil it. Does it work? Does it work?
Yes.
Think about the process that Mark described. Do the first term, boom. Do the last terms, boom. Now do the inner and the outer. Negative 9, positive 4, you get the middle number. Yep, that's the one. Any questions about that? Any concerns? Okay, let's try it again. 6x squared plus 13x plus 5. Start at the beginning of the sequence that you are being trained to be an expert at. Start with GCF. See if there's a GCF. If there is, great. If not, next step. Is there a GCF?
No.
No, there is not. Can we factor this easily by just unwrapping the foil? No. Natalie, how come? Yeah, there's a number other than 1, which leaves us with what option? What's our option now? Diane? Well, no, I'm asking what's our option now? What are we left with in that sequence? What do we do now? Don't tell me specifically, tell me what overall process are we going to do. Talking about these things up here. Okay, well, it's all right. I don't know if you understand what I'm asking. Sean, what was I asking? The trick. So now it leaves us, Dion, with the trick. We did everything else. We checked everything else. So now we're with the trick. So do the trick. No calculator is needed. Nope. So, anyone got the first step? Second step? Give me something. Go ahead, Tatiana. So we start with the 30. What are the two numbers we're going to use? Kians? 10 and 3. What do we do with those two numbers? Aaron? Put them over A, which in this case is 6. Very good. What do we do next? Gloria, you already finished? Okay, what do we do next? Good. What do they come out to? 5 over 3 and 1 over 2. Very nicely done. And that is the result we were looking for, the magic fractions. The magic fractions easily give us the factors. And so, now we fill in 3x plus 5, 2x plus 1, and now I'm going to mentally FOIL it and make sure that I didn't make a simple mistake. That's 6x squared, that's 5, that's 10, and that's a 3, and so it works out. Anyone have any questions on how we factored this? Any questions or concerns? Any issues? Okay. Checkpoint number 1. Let's see how you do on these two. Definitely still takes a little bit of work, so I'm going to put 4 minutes on the clock. Remember, if one of my supervisors walks in the room, I'll try to indicate it somehow, and you need to slide your cheat sheet underneath your paper and pretend like you're doing it a different way.
Yeah.
All right. See how we did? Part A. I've got students 16 and 21. Student 16, what'd you get?
2x plus 3 times 3x.
Okay, student 21.
2x plus 3 times
And part B, I got student 19 and student 14. Student number 19.
3x minus 4,
Okay, student 14. X minus 2 times 3x plus 4. Now again, several answers were expressed with one factor in a different position. That's fine. As long as you have the 3 and the 1 together and the 2 and the 3 together, you can take this whole factor and move it over here and this whole factor and move it over there. That's fine. That doesn't affect anything, just like 6 times 3 is the same thing as 3 times 6. Were there any questions on either of these? Seemed like we had some errors. Any issues? Any thoughts? Any observations? Because now we need to go to the next step. I want to make sure you got this down. Any thoughts? Okay, you guys are doing well. So, let's build on that. And this is example 2 for you guys, so just go ahead and write example 2. Without going into a long explanation right now, eventually there will be, but right now I'm not going to. We do not want to deal with a negative a. We don't want to deal with it. In fact, in our factors, we don't want our factors to be negative out front either. So you'll notice that this is not negative, that's not negative, that's not negative, that's not negative. This is negative, and that's okay. But we don't want any of these to be negative. So, one thing we're going to get used to doing is anytime you have a negative out front, you are going to factor out a negative 1 as a greatest common factor. It's going to take you a moment to understand, but it won't be a big deal once you get used to it. Okay? Think of it this way. I want this to turn positive. Well, I'm not allowed to just go like that. You're not allowed to do that. You can't just change a number. But you can rewrite things in a way that the number will look the way you want it to look. But you might have to add something in or take something away. So if we use distributive property going in reverse, and we factor out a negative 1 and put a negative 1 outside the parentheses like this, we can have what's left over the way we want it. Because remember, what's going to happen is this is going to get distributed and we'll end up with this up here. So what we're going to write here in the parentheses is what's left over. This you've done before. So what would have to go in the first position so that when I multiplied it by negative 1, it came out to negative 2x squared? Go ahead, Deja. 2x squared. So now all of a sudden it's positive. What would I have to go in the middle position so that when I multiplied it by -1, it would come out to -5x? Emily? 5x. Well, that sign changed also. And what would have to be in the last position so that when I multiplied it came out to -3? Bontravis? 3. And so now I have a factor. -1 is actually a factor now. And I'm going to need that at the end. But I also have this whole thing left over. This is left over. And now the leading coefficient, the number out front, is positive. And now I can proceed with my methods that I've learned. So now I can say to myself, well, is there another greatest common factor that I can factor out? Well, I have a 2, a 5, and a 3. No, there's no common factor. Can I unwrap the foil very easily? No, because as Natalie taught us, if there's a number other than 1 there, you can't. So what method are we left with? Milan? Well, what method are we left with? The trig. So here's what I want. I want at the end, I want to say -1 times a binomial factor times another binomial factor. I've already found one factor, -1. Now I need what goes here and what goes here. Some of you might be able to not use the trick, and you might be able to just do it using trial and error. If you can, great. If you can't, then we do the trick. And now at this point, you've done the trick, what, 5 or 6 times. So now you should know the first step with no problem. What's the first step? What's the first step, Christian?
8 times c.
In this case, it is?
-2 times
No, we're here now, and I'm sorry. So we are no longer looking up here. That original does not exist. We do not want to use that. That's why we That's why we rewrote it. That's why we rewrote it without the negative. So this no longer exists. We don't want this anymore. We didn't want it in the first place. We want this, what's written in purple. So A times C is going to be what?
2 times 3.
Which is?
2 times. Oh, 6.
6. Wonderful. And now I need two factors that multiply to 6 and add to 5. What are the two factors? 1, 2, 3, 4, just 5 people can do that? 6 people can do it? Go ahead, Tatiana. 2 and 3. What do we do with those two numbers, Shannon?
Put them above A.
Put them over A. Very good. What do we do next, Isabella? Simplify. So 2 over 2 is really 1 over 1. 3 over 2 is already in simplest form. And now we've got the magic fractions. Now those become the factors. X plus 1, 2x plus 3. But now we have 3 total factors. -1 is a factor. X plus 1 is a factor, and 2x plus 3 is a factor. And that's what we were looking for, all of the factors. Anyone have any questions on how we did this one? Any questions about that? So now, moving forward, anytime there's a negative out front here, we want to address it immediately by getting rid of it. Okay? Any questions? Any questions? Because I don't think we need this. I think you're going to try it on your own. So you try 2 of them on your own. I'll give you the big hint. You have to get rid of the negatives first. Factor out a negative. And then work from there. takes a little bit longer. You got 4 minutes on the clock. If you need to, of course, ask for help, talk to your teammates quietly, whatever you need to do to get success. Or got quite a few people still working. Give me a thumbs up if you finished both of them. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, put your thumbs down. My students who are done, be patient for 1 more minute. I want my students to have a chance to be successful. 1 more minute, but then that will have to be the time. Go ahead and finish up. If you're already done, check your answers with your teammates to see if you got the same thing.
gotta answer.
All right, now let's see how we did. Colored pen up. I got student. Move this. I got student 11, 14. Student 11, student 14. What'd you get for part A?
-1 times x plus 5 times x, 3x plus 2.
Okay, student 14.
-1 times x plus 5 times 2x plus 2.
That is correct. Very nicely done. Part B, I've got student number 13 and student number 2. Okay, I got student number 2 and student number 8.
-1 times 4x plus 5 times x minus 1.
Okay,
-1 times x minus 4 times 4x plus 5.
is that what you said, Angela? Very good. Anyone have any comments, any questions, any concerns? So one major difference between the second checkpoint and the first was factoring out a -1. I want you to keep in mind something going forward on a quiz or test. If you did all of this and on your answer you forget to put the -1, I will mark it wrong. -1 is a factor that must go along with the rest. Any questions about that? That's the same thing. That's the same thing. Very good. Your homework is on page 391. You're doing numbers 1 through 18. You also have your study guide for your quarterly exam. Your quarterly exam is Thursday,